welcome back to our YouTube channel. In this video, we are going to learn about the adjoint of a matrix. The adjoint is very important because it helps us to calculate the inverse of a matrix. So by the end of this video, you know how to find the adjoint of a 2 by 2 matrix and a 3 by 3 matrix, and you also see key properties that connect adjoints and determinants. Okay, so let us start. So the adjoint of a matrix is denoted by adj of A. So if you want to write the adjoint of a matrix, you just denote it by the adj of A. That just shows the adjoint of a matrix A. And this is the same as the transpose of a cofactor matrix. Okay, so let us start. There are two. To find the adjoint of a 2 by 2 matrix and to find the adjoint of a 3 by 3 matrix. So let's start by a 2 by 2 matrix. So let's start with 2 by 2. This is very quick. So if we have a matrix A, which is A, B, C, and D, then the cofactor matrix is going to be, so here A and D are at the diagonal. So we have A and D at the diagonal. So we exchange them. We switch their positions. So this will be D and A. And then this sign, B and C, the two which are not at the diagonal, we switch their positions and change their signs. So here will be C and B, and then we'll change their signs. So this is the cofactor matrix. So the adjoint of A is equal to the transpose of the cofactor matrix. So now we have to take the transpose of this matrix. So the transpose of this matrix, remember the row becomes the column. So this first row becomes the first column, which is D minus C, and the second row becomes the second column, which is minus B and A. So this will be the adjoint. So the adjoint of that matrix A will be D minus B minus C A. Okay, so let's have an example. Let's have a matrix A 2, 3, 1, 4. Okay, so the adjoint, so we need to find the cofactor matrix. So remember, you switch the positions of every element. So those at the diagonal, you switch them. So we have 4 and 2, and then those which are not at the diagonal, we switch them and we change their signs. And then you look for the transpose of that matrix now. So this will give 4 minus 1 minus 3 2. But why go through this long step when we can just do this? We can just say A, we switch the positions of the elements at the leading diagonal. So we have 4 and 2, and we just change the signs of these which are not at the diagonal. This is minus 3 and minus 1. So this is just, we just do like this, then for us to find the cofactor matrix, and then we take the transpose. So we just simply interchange the elements at the leading diagonal, and then we just change the signs of the elements which are not at the leading diagonal. But remember, this is done for only a 2 by 2 matrix. It does not apply for a 3 by 3 matrix. It does not. So let's have another example. Let's have a matrix B, which is 4, 8, 1, 5. Let me just have negative numbers. Okay, so simply to find the adjoint of that matrix, to find the adjoint of B, we simply interchange the elements at the leading diagonal, which is 4 and minus 5. We interchange them, and then we change the signs of those which are not at the leading diagonal. So here we have 8. It was minus 8, so the sign changes to 8, and now we have minus 1. So that is it. That is all for a 2 by 2 matrix. Now let us have a 3 by 3 matrix. Let's go to the next, which is 3 by 3 matrices. Now this is more complicated than a 2 by 2 matrix. So let's go straight to an example. Let me just have an example. Let's say we have C is equal to 2, 1, 5, minus 1, 2, 3, and 4, 1, 7. So here we cannot just do it like we did for 2 by 2 matrices. So this has another step. Okay, so let's take it step 1. We are going to write this matrix 4 times. So write it 4 times. I mean 2, 1, 5, minus 1, 2, 3, 4, 1, 7. So we are writing it the first time. So now we'll write it to the left. 2, 1, 5, minus 1, 2, 3, 4, 1, 7. Now we go below. 2, 1, 5, minus 1, 2, 3, 4, 1, 7. Write it this way. 2, 1, 3, minus 1, this is 5. 5 minus 1, 2, 3, and 4, 1, 7. So we have written it 4 times. This is the first time. This is the second time. This is the third time. And this is the 4th time. So we write the left, top right, bottom left, bottom right 4 times. Okay. So now we eliminate one line like this. We eliminate the outer numbers. So we eliminate the outer numbers. So we have eliminated these numbers at this extreme end. So we are left with those inside. Okay. Now what do? We have to pair them. So we have to pair them to give us 2 by 2 matrices. So this is our first 2 by 2 matrix. This is our second 2 by 2 matrix. This is our third 2 by 2 matrix. We go down. This is one 2 by 2 matrix. This is another. This is another. This is another. This is 1. And this is 1. Okay, so This is a little bit confusing. Let me just write down what is inside here. So let me write it down. So we have 2, 3, minus 1, 2, 1, 7, 4, 1, 1, 5, 2, 1, 2, 3, minus 1, 2. So our step 2 now, so we have written it down 4 times and we have eliminated the outer elements, the letters at the numbers, at the extreme ends. So now we have what is in the middle. So we pair them by 2 by 2 matrices. So this is 1 2 by 2 matrix. So we compute that, we simplify that, we look for the determinant of that 2 by 2 matrix. Now we look for the determinant of this, which gives us 1 element. We look for the determinant of this. So when we look for the determinant of this, it will give us our first element A. When we look for the determinant of this, it will give us B. When we look for the determinant of this, it will give us C. When we do this, it will give us D. When we do this, it will give us E. When we do this, it will give us F. When we do this now, it will give us G, H, and I. So this A, B, C, D, E, F, G, H, and I. So we have A, B, C, D, E, F, G, H, and I. So this now will be our final cofactor matrix. So that will be our final cofactor matrix when we have that. So remember the formula to find the adjoint. The adjoint was simply the transpose of the cofactor matrix. So if this A, B, C, D, E, F, G, H, I is now our final cofactor matrix, now we have to get the transpose of this. That will give us the adjoint. So that is how we look for the adjoint of a 3 by 3 matrix. So that was our first step. Now our second step, we take each 2 by 2 matrix and look for the determinant. So we have this now. So let's take the first case. Let's take the first case, which is this our first 2 by 2 matrix. So let's look for the determinant of that. We have 7 times 2 minus 3 times 1. So that will be the determinant of that first. So let me change the color to differentiate it. So that's our first 2 by 2. Let's take the second 2 by 2. So that now will give us 3 times 4 minus 7 times minus 1. So we are taking each 2 by 2 and looking for their determinants. So the first 2 by 2 will give us the first element, will give us A. The second now will give us B. So let me take the next. So now let's take this. Are these the same? Let me take this. Let me change the color to not complicate things. So now we have that. So it will give us our third element, C. So it's going to be minus 1 times 1 minus 4 times 2. So the elements at the diagonal, the leading diagonal, minus those which are not at the diagonal. So that is that. So let's go now to the next 2 by 2. So this is our next 2 by 2. So that is now going to give us our D element. So we have 5 times 1 minus 7 times 1. Let's take the next two. So that is 7 times 2 minus 5 times 4. Let's take the next two. So it is 4 times 1 minus 2 times 1. Okay, that gives us F. Now G will be 3 times 1 minus 5 times 2. This gives G. Now H will be this 5 times minus 1 minus 3 times 2. So let me just put that in bracket. So minus 3 times 2. So our I will be this. So H is this. So our I now will be that. So it's 2 times 2 minus 1 times minus 1. Okay, so this is what we have now. So I'll just put in them in different colors, not to show you guys which 2 by 2 we are taking and at what time. So now let us simplify them. Let's simplify. Now we have 7 times 2. That is 14 minus 3 for the first case. 12 plus 7 minus 1 minus 8. Now we have 5 minus 7. 14 minus 20. 4 minus 2. 3, this is 5. 3 minus 10 minus 5 minus 6 and 4 plus 1. So all these together, 14 minus 3, that's 11. 12 plus 7, 19. Minus 1 minus 8 minus 9. 5 minus 7 minus 2. 14 minus 20 minus 6. 4 minus 2, 2. 3 minus 10 minus 7 minus 5 minus 6 minus 11. 4 plus 1, 5. Now that is our cofactor matrix. So our cofactor matrix is 11, 19, minus 9, minus 2, minus 6, 2, minus 7, minus 11, 5. So remember, the adjoint is equal to the transpose of the cofactor matrix. So now we need to take the transpose of that matrix. So that is the matrix of cofactors of A. That is that. And now we need to take the transpose, and when we take the transpose, that will give us the adjoint. So the adjoint now is a transpose of that matrix, which is the row becomes the column. 11, 19 minus 9, minus 2, minus 6, 2, minus 7, minus 11, and 5. Now that is the adjoint of a 3 by 3 matrix. That is finally the adjoint of a 3 by 3 matrix. So that was step 2, sorry. Now this is step 3. So remember to find the adjoint of a 3 by 3 matrix. We need to find the matrix of the cofactor, and we take the transpose of that matrix of the cofactor, and that is how we find the adjoint of a 3 by 3 matrix. So that is all for today, guys. Thanks for watching this video, and I'll see you guys in the next video.